Hello dear, welcome to the another series of experiment which is Hola ChemX, hands-on lab chemistry experiments, or we can say home lab chemistry experiments, organic chemistry experiments. In this video I would like to demonstrate you how you can perform simple esterification reaction at home using two ingredient which is called glycerol or glycerine and then citric acid. When we heat these two ingredients, basically we form a ester bond, and this ester bond this esterification happen many times in this reactions, and which give a biodegradable polymer. So this reaction is very easy. We need either oven or microwave, so we can perform at home. So let's start to perform this esterification reaction at home, and I hope you will enjoy this experiment. So let's understand this reaction. Basically this is a esterification reaction, but it is called catalyst free. Usually esterification reaction require concentrated sulfuric acid or acid, then esterification occur, but in this type of reaction this is a catalyst free esterification reaction which make a biodegradable polymer. So here glycerol, this is the structure of glycerol, which have two primary alcohol and one secondary alcohol. Common name is glycerine. This is molecular formula. Molar mass is 92.09 gram per mole. Density is 1.26 gram per ml. Plus citric acid. Citric acid have 3 carboxylic acid, 2 primary and 1 secondary carboxylic acid and 1 secondary alcohol. So these are the chemical structures. When we heat this two ingredient in 1:1 mole ratio, then it remove the water and ester bond formation occur. But here you can see in once ester bond form between the glycerol and citric acid, is still primary alcohol on glycerol and primary carboxylic acid in the citric acid remain open. Therefore this product act as a reactant and it again polymerize, so it again esterified. So this is why it's called polyesterification, and after polyesterification we get a polymer where you can see many glycerol and citric acid keep reacting and they form ester bond, which make the biodegradable polymer or green polymer. So P for polymer, on both hand it makes a very long chain of polymer. So this is very good example of the reaction which we can try at home. And let's see some more important topic here. So synthesis of glycerol or citric acid polymer, which is called green polymer, and this is a eco-friendly approach. Synthesis of plastic biomaterial, you can synthesize plastic biomaterial which give a biodegradable polymer, but biodegradable means bacteria, fungi, algae and other microorganisms can decompose this one. Even water hydrolyzes also. This is a condensation reaction, and reaction affect by the length, means time, how long we do the reaction, and the temperature of the heat or bake. Basically it's like a baking or curing. This polymer made from the renewable resources, this polymer break down into non-toxic component through water, so it hydrolyzes with water as well. Next is we'll see what are the applications of this biodegradable polymer. So the application and uses of degradable polymer made from the glycerol and citric acid are suitable for 3D printing applications, and mulching film, making mulching film for the agriculture purpose, seed coating, and then in timed release for herbicide, pesticides and nutrients. Next is in time release for the drug, so you can use in drug delivery purpose also to control the rate of the drug delivery, and disposable packaging, making plasticizer and more. So this is very easy making polymer. So let's see what are the ingredients are required here. So first here we will see what are the material required or ingredients. So first thing is this glycerine, which is a common name, and here I have taken this glycerine which says 99.5% anhydrous. It means very small amount of water is there. And the commercial name or chemical name is glycerol. It have the chemical structure, this one. And another reactant would be our citric acid. So the natural source of citric acid is the lime, so we can take out the lime juice. So lime is a natural source of citric acid, and this is the chemical structure of citric acid. So here we have glycerine, citric acid, or we can use this lime juice, which is also commercially available. It says 100% lime juice, but when I read the ingredient, it has some other chemicals or preservative. So we can also try with this one. Next is here we have solid powder citric acid. So this we can also use, or this is available in grocery stores. So this is the citric acid. So here we have three different types of sources for citric acid. We will try these one by one. Next is we need some small measuring cups and a dropper. So measuring cups and dropper. If you have a balance, that would be great. So here is my balance to weigh. This is the thermometer. I mean, if you have different type of thermometer, that's okay, but this is the only I have thermometer in my home. And we need another strainer or filter to filter lime juice. Then here I have taken some cups, plates and a spoon. So I have taken here some small cup, it's a big cup, spoons and 3 plates, and few paper towel. Next to heat we have here oven. So this is my small oven. I can try to heat our reactants, and or if you don't have oven, we can use this microwave oven. So we can also use this microwave oven. So let's start our reaction now. So now we will do the experiment number 3 with this solid citric acid powder. So this is the third experiment with this solid citric acid powder. So let's weigh our glycerine and citric acid. So you can use any plain paper, make a boat like this, and I will take around 10 grams of citric acid. Let's see how much we are having. Okay, it's around 10 grams citric acid, which is, it seems a lot. It's a huge amount of powder. 10 gram, and then I'm taking here glycerine around 5 gram. A little bit more. Let's That's it. Then transfer all of this citric acid powder here and glycerine. Mix these two together, and of course it is not easily soluble, so we need to heat. I will use this type. So first make this kind of paste. So here you can see this look like a paste. Let's heat this in microwave first. For 10 seconds only. And then so as you will heat, it will become liquidy and start dissolving. So here you can see this is nice liquid. Let's mix again. And then keep it again inside. Okay. So it is dissolving and become liquid. Temperature is right now increasing. Next, once again. This is the third time. I have around 5 So now you can see it look like liquid. It's all liquid. As we will keep increasing the temperature, it's hot right now. So let's check the temperature. What is the temperature right now? This side. So the temperature is within a 30 second. Temperature is around 54 degrees Celsius. It's still keep increasing. 60 degrees Celsius. And it's around 65 or 66. Okay, so let's mix again. You need to keep mixing a lot, so citric acid should dissolve. This is number 4, heating. This is really hot right now. Be careful. Ooh. Cannot touch it. Let's check the temperature again. Temperature is around 77 degrees Celsius. Is still increasing. So look like solid citric acid is much better than, it's almost getting closer to the 90 degrees Celsius, you know, which is nice. Third time over here. And now we'll do, let's keep mixing first. We need one more plate to transfer it into new one. Now you can see it's almost dissolved everything. So let's heat once again. Now you can see it start boiling, very hot. So be careful if you are doing this reaction. And temperature would be probably above 100 degrees Celsius. My thermometer is more than, it cannot read more than 200 degree Fahrenheit or 93 degree. You can keep mixing as well, you know. Temperature is around 82 degrees Celsius, around 80 degrees Celsius. Okay. And color is slowly become pale yellow color. I will give one more 10 seconds. It's very hot right now. And that's it. This should be fine. It is very hot. Let's keep mixing. Now probably will do one more last maybe 5 seconds only. Okay, again one more 10 seconds. And now it's very hot. I'm going to pour directly into the plate. And then we'll keep it for coming at room temperature. So this is third experiment product. Now again we'll cool at room temperature. So these are experiment number 1, this is from experiment number 2, this is experiment number 3. Now it's time to analyze them after cool down. Okay, so now after 1 hour we will do the product analysis and quality test, see how our product is we obtain. So let's check. So this is the lime juice. I would like to show you this in the water. So here you can see this very easily. So lime juice is water soluble very easily. Another test is with the water, and then this is the commercial lime juice. If you will add this into water, this is also very easily dissolved lime juice, water soluble easily. Now we'll check water and then solid citric acid. So if we will dissolve some of the solid product and shake it, so you can see this citric acid, which is solid, is also water soluble very easily. And next is this is glycerin, and glycerin, if we will dissolve this in the water, this also so glycerol or glycerin is also dissolved easily in the water. Now we will test the product. Now we will see the polymer product from experiment number 1. This is basically, if you will see, you can see here it's still liquid and slightly yellow color. So pale yellow, liquidy, and smell is a juice smell. Let's see how it will dissolve in the water. And so probably we need to give some more time for heating. Not very good. Next example, the product from the experiment number 2, which is from, this is kind of semi, this is also liquid, and let's see how is it going to dissolve. This is like a chunky type of polymer, or easily dissolved. So pale yellow, liquidy, and lime juice smell we also obtained here. How about the third one, the polymer product, which is from the experiment number 3, and here you can see this is basically transparent and semi-solid or gel type and no smell. So if I try to scrape it from the spoon, it's very sticky. Yeah, you can see here. So this is good polymer or gel type of product we obtain, and you can make a, so this would be good product. And here if you will make a water, and you can add directly into the ball, so this will stick at one place, so which is good. This is very good. So this is our real product, polymer product, which we have made it coming from the product experiment number 3, which is transparent and semi-solid and no smell. So here you can see the product which we obtained from experiment number 3. It was very good quality product, polymer product we obtain, and here you can make a ball, or you can make a like a 3D printing wire or something. If I will scrape like this one, you can make a ball. This is a good indication that our polymer is, we got it, the polymer, you know. So you can make a ball or something like that. So, and still it is in water. So here you can see, but they are all water soluble. So here you can see this is the difference between the previous product and this one. It's very not easily soluble in the water, but later on they will all dissolve. So we got the product here, which is nice, good quality product. So you can perform this experiment at home and then see how you will get the product. I hope you will enjoy this experiment. So thank you for watching.